Hello, my name is Aaron Park, and this is 7th grade, lesson 20. So, to start off, number 1, Irene paid $14.20 for 4 kilograms of strawberries. What was the price of 1 kilogram of strawberries? So, we know that it was $14.20 per 4 kilograms of strawberries. And we want how much money it was for 1 kilogram. As you can see in the equation I just set up, to get this answer to solve for our x, we simply need to divide both sides by 4. And by that I mean, we just need to divide 14.2 by 4, as this fraction shows. So if we are to do long division and show our work, we can see that 4 goes into 14 3 times. The 2 comes down, 4 goes into 22 5 times, and then it goes into 25 times again. So if we stick a dollar sign in front of that, we can see that our price for 1 kilogram is $3.55. Number 2, solve the problem below and mark the correct answer. So we have a simple division problem. We can write it out as a long division problem, like this. We notice that negative 48.48 is divided by negative 12, so the signs we can simply cancel out. We can ignore them. 12 comes into 48 4 times, and based on that, we know that it just looks like this. 4.04 positive. This problem is just like number 1, so I'll let you do that on your own. Now, number 4. A rectangular parking lot looks like this. The area is 610 yards squared. The length of the parking lot is 25 yards. So, what is the width? Since we know that area equals length times width, we know that this is 610 yards squared is equal to 25 and our width. We divide both sides by 25. 25 cancels on the right, leaving just x, and here, once again, it is just division. It goes into 61 2 times. 2 times 25 is 50. It goes into 110 4 times. 4 times 25 is 100. Bring down another extra 0. And then another 4 times. 24.4 yards. This is, again, division. And then here we have a more interesting problem. He went to London, which is a city in Britain, London, the capital of Britain, in fact. And in order to do so, the British use pounds as their currency, not American dollars. So he converts the money over. They give us how much he started and what it turned into. So now we need to know the exchange rate. So we can see that we want it in pounds for dollars. So now erase the dollar sign because it should be the pounds on top and the dollars on the bottom. Equals how much for $1. And then we simply divide. How many pounds? Well, 33 and 55. This is not the most pleasant number to do, but it's effectively the same as 5 dividing 3, because both of these are divisible by 11, which we know is 6. 0.65 and a 3. A. And this makes sense, logically speaking. The exchange rate should be smaller because his $55 turned into 33 pounds. 33 is less than 55. Now it looks like we have a lot of slope problems. We simply need to find the slope of the straight line that passes through these points. So, graphically speaking, -2, -1 is somewhere here, and 4 5 is somewhere here. And then we want a line that looks like this. So, in order to solve these kinds of problems, it's very helpful if you know the ways to write a linear equation. In this case, since we have 2 points, oh wait, never mind. It's only the slope of the line, not the equation of the entire line. This makes it rather easy, because the slope of a line, represented by the letter m, is the change in y over the change in x, which we can find by simply writing the coordinates of one point subtracted by the other. So if we start with 4, 5, the y value is 5 and x value is 4, minus the other point, -2, -1. The y value is -1 and the x value is -2. Notice that we are subtracting a negative number, so this can basically just become a big plus sign. It's the same as adding. 5 minus -1 is the same as 5 plus 1, which is 6. 4 minus -2 is the same as 4 plus 2, which is also 6. This simplifies to 1. Our final answer, the slope of the line, is 1. We can repeat the process for all of these problems. I'll do number 6 and leave the rest to you. 3 minus -3 over 7 minus 1. The y values and the x values. Then this turns into 6, and what would you know? This turns into 6 as well, giving us 1 once again. Now for these word problems. Ocean water levels are measured hourly at a monitoring station. The table shows the water level in meters on one particular morning. Find the rate of change in water levels, meters per hour, throughout the morning. Write an equation with y as water level and number of hours as x. Now we are writing the equation. So first it asks for the rate of change. The rate of change is given by the slope of the line, and we just got through how to solve the slope. Now we're given not 2 but many points. Any 2 will work. I'll use the first one because it has a 0, which makes the math easy, and the one right next to it. Now it tells us our water level is y, and our number of hours is x. So 9 minus 3, 9 and 3, 3 minus 0 equals 6 over 3 equals 2. And then it asks the rate of change in water levels, meters per hour. So we make sure to add our units, meters per hour. And it is positive. The water level is rising. Next, we want to write the equation. Here is when it is helpful to know the different forms. In this case, since we have a bunch of points and we solved for the slope, the one we want to use is point-slope form, which looks something like this. y1 equals mx minus x1. Here, x and y are variables, m is the slope, and y1 and y2 are the coordinates of a point that we'll plug in. Once again, I'll choose the first point because it has a 0. So y minus 3, because 3 is the y, equals our slope, 2x minus 0. Now we can simplify, or at least move this 3 over to the other side and distribute the 2. Now we note that this is 0, so reality this is just x. Our final answer is y equals 2x plus 3, because I assume they want it in slope-intercept form. Now that is all for today. Thank you.